whoa, that is fast. Wow. Wow. That generated, like, did you see that? That was so fast I couldn't see it. Oh, cool. Oh, wow, that's fun. So I can press, wow. Okay, so that's a pretty darn cool effect, right? I think that's pretty neat. Hey y'all, it's Dr. Know-It-All. Welcome to InceptionLabs.ai. This is a new way of doing token generation, which is much more akin to the way that you would generate an image. If I said generate an image of a person with a mug, you know, something like that, that you would use diffusion models these days to do something like that. Well, large language models have traditionally, in the last several years, have used token generation based on autoregressively trained transformer models. In other words, that's the kind of stuff that we've talked about a lot previously on this channel, and many other channels have talked about that as well. We've used transformers to do language, and we've used diffusion models to do still frames and now video and some audio as well. If you want to check out videos about this, I'll put a link up here and also at the end of the video. I think it's highly worth talking about that. So what Inception Labs has done that's very different is that they've used diffusion models to actually generate tokens for a language model rather than using the transformer architecture. So this is really, really cool. This could unlock a really interesting way of thinking outside the box in a way. Next token generation is very linear. It's like generate this token, then look at what you've got right now, then generate the next token, then look at what you've got right now, then generate the next token. And then, you know, so it's like thinking in a very, very linear fashion. What diffusion models could give you for language processing is kind of an overall sense of what's going on, right? It can think about the big picture in kind of a literal way. That's the way that diffusion models work, is that they start with noise and they denoise the image to something that you have asked for, like a panda riding a bicycle or a person holding a salmon colored mug, you know, something along those lines. You start with noise, you put in the text that you're interested in, and then the neural networks denoise that image back to something that you had requested. So what you're doing here is, instead of denoising an image into some sort of image, you're denoising noised language into actual words, into tokens that you can predict. The big outcome of this is that you get massive, massive speed ups, and it's supposedly a lot cheaper as well, like 1,000 tokens per second. Really, really fast stuff. So currently I'm on chat.inceptionlabs.ai, which is their chat interface, their playground. I'm here. I believe that there is, we only have 10, requests per hour or something. So I'm going to do sort of minimal testing. And given the fact that the website seemed a little bit overwhelmed this morning, I'm going to actually do the requests first and do some basic testing until I run out of the ability to do more testing here, if it breaks or something like that. And then I'm going to come over here after I do that and explain exactly how this works using their research paper that they did, which is it's not a fantastic research paper, but I'll just start with this graph. This is what I was talking about. You get good intelligence and really, really fast output of, 750 tokens per second or so, which is way higher than these other models are capable of doing. So that's their big benefit, is that they're able to generate tokens at a very, very high speed and also have reasonable, coding and analytical ability. So anyway, back to the playground. You can see it says it's a coder. I will ask some other questions just to see. I'm also going to turn on this diffusion effect. I literally have not used this before because I was scared of using up the, the inference requests and things. But I will start off with a, relatively straightforward question. Write the classic Space Invaders game in Python using Pygame, scoring, blah, 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 blah. So let's go ahead and see. What we should see is something relatively quickly. And again, I don't know what this diffusion effect is. I don't know if we'll be able to see. Whoa, that is fast. Wow. Wow, that generated, like, did you see that? That was so fast I couldn't see it. I don't know if there was necessarily some sort of diffusion effect, but anyway, I'm going to go ahead and copy the code, which is, it's about on the order, 125 lines or so is about on the order of what I've seen other, coding things do for this. I'll go ahead and copy this into VS Code and we'll give it a run and see if it actually plays. All right, so firing it up over here and okay. Well, I saw something. Okay, let's go ahead and give this another try. I don't know exactly what's going on. Okay, oh, they all immediately descended to the bottom. So I guess I lost immediately as soon as I tried to fire. You could see that it was actually doing something correct, but absolutely, did not work properly here. So I'm going to go ahead and request that it make some updates to the game. I'm not exactly sure, since it didn't throw an error, I'm not exactly sure what to type in. So I'll just try to be descriptive in my feedback. Okay, so I descriptively, said what went wrong, and then I asked it to add a scoring system and also an end screen, so I can actually just, restart instead of having to refire up the entire thing. So let's see, it looks like it's thinking. I'm not exactly sure. It's doing something here. So yeah, I don't know. So again, I think that their servers are probably overwhelmed. This is a small company. They don't have access to massive servers. So, you know, it's probably expecting too much. You could see when it actually launched the thing, it actually worked incredibly quickly. But unfortunately, it does not seem to be doing much of anything at the moment. Alrighty, so while we are stuck on this, let's go and look at Inception Labs' discussion of what they did with this diffusion model. So the first commercial scale diffusion large language model, so that's their thing as I talked about earlier. We trained diffusion large language models that are up to 10x faster and cheaper than current LLMs. That's impressive, 10x faster and cheaper. Cheaper is a big deal right now. ChatGPT 4.5 just came out and their million token output rate is kind of crazy. I think it's $175 or something. I need to check on that to make sure that that's accurate, but it's a very lot of money. So having something that's much, much cheaper is going to be a big deal. Now, of course, it's got to operate as well as the transformer architecture. But again, you know, let's call this a 1.0 product along the lines of like GPT-2 or 2.5 or something like that, right? From a few years ago. This actually, it's significantly better than that, but I'm just saying this is a very early product and there may be quite a bit of headroom to grow in terms of diffusion models. Anyway, so they say they're pushing the frontier of intelligence and speed for large language models, and you can see that it's working through autoregressive. This is completed, so they're basically showing that they work a lot faster. So anyway, their big takeaways. We're announcing the Mercury family of diffusion large language models. Cool, Mercury, speedy, messenger, get it. DLLMs, I like that. A new generation of LLMs that push the frontier of fast, high-quality text generation. Mercury is up to 10x faster than frontier speed-optimized LLMs. Our models run at over 1,000 tokens per second on NVIDIA H100s. It's crazy. A speed previously possible only using custom chips like Grok, I would assume. A code generation model, Mercury Coder, is available to test in a playground. We offer enterprise clients access to code and generalist models via an API and on-premises deployments. I have requested, there's a thing at the bottom that says request access to the API and you get on a wait list. So I have done that just to see. And by the way, anybody from Inception Labs that wants to come on my channel and talk about this, I would love to. We can talk about it in as much detail as you want or are able to talk about. This is really, really cool. I think this is awesome. I've talked previously about how, you know, diffusion models and large language models, they're kind of the two main pillars of modern day AI and the idea of bringing them together in a sense. Now, this doesn't really bring them together. This just supplants transformers with diffusion models. But, you know, I could see an eventual sort of hybridized model of this. There have been some attempts in the past. But anyway, it's just really cool to see crossover between these two things. And I think that there's some real possibility. The big thing that I think you can get is kind of like holistic thinking, right? I said that earlier. I think that large language models based on transformers are very, very linear. So even if you're doing chain of thought or explain your reasoning or like an O1 model or something that's a reasoning model or DeepSeek's R1 or whatever, those models are still necessarily linear because you're always going token, you know, put that in the window, generate another token, put that in the window, generate another token, you know, so it's always in a very linear fashion. This has the capability of thinking in a more non-linear method. So I could see this potentially thinking in a liminal space and then potentially combining it with a transformer-based model to do inputs or outputs or something so that you can use the benefits of the transformer models perhaps as an input space to put this into a liminal space. Then you could use these diffusion models in the liminal space to generate your thoughts and then perhaps for polish or something like that. I don't know because this is very early and I haven't been able to test it that well. Obviously, it's still thinking, hasn't really gone very far. So there's limited amount of experience that you can have with this model at this point. But as we understand it better, some sort of hybridized model that uses both of these things, the benefits of diffusion models to be able to do holistic thinking, the benefits of transformer models to be able to do very large windows, you know, that they have context windows that are huge, and the ability to kind of maintain memory and chains of thought and things like that. So anyway, we will see where this goes, but I think this is really cool that we're talking about having a diffusion model that does text as opposed to images. So anyway, back to this, this picture that I showed previously. They've also got a Coder Mini, which I don't think we have access to at this point, but that's 1,100 tokens per second. So kind of crazy levels. Now Grok, G-R-O-Q, actually can do things at very, very high high speeds. I think multiple. I'm going to be probably wrong, but depending on the model, I think you can get up to like 500 or 600 tokens per second. So it closes in on Mercury Coder, but it's still, you know, we're talking about something amazing, and especially if it's really, really cheap, that's super cool. All right, so I started over again here, just taking a quick break. I looked over on the coder thing. So I'm going to go ahead and ask it. The new chats, apparently, maybe that other one was a new chat. Okay, so this time it did better. I actually put in the error correction stuff. So this is actually shorter than the previous one. So let's see if it works better. That is interesting. All right, so copied over into VS Code, invalid syntax. Oh, boo. So it didn't do as well. That's unfortunate. All right, there we go. The last one clearly did not fully generate and it wasn't finished. So this one is, and it's significantly bigger. So that makes more sense. So let's go ahead and fire it up. Okay. Okay, we got a scoring system. Lots and lots of bullets. I like that the bullets actually have some length to them. That's kind of cool. See how they're not like just 1 pixel wide. They're actually, let's see if I can actually shoot this guy. All right, and there we go. And hopefully we will have levels. Oh, good. Oh, wow. Pretty easy to kill these guys, but you know. Oh, and I can also hold it down and get continuous firing. So, you know, there's basically this is making it pretty easy. So, yeah. So anyway, I would consider that good. I'm not going to wait for it to go ahead and get to the end screen, but that's pretty cool. So I'll give that a thumbs up. That worked very, very well on a second try. And I know this isn't code, but let's try something different and see if it can answer a logic question. So we're going to force it to go outside the box just a little bit here. Wow, that's crazy. Did you see that? So it got 11 games. That's great. And it did it incredibly fast. I actually wish that I could see what it's doing, because you can see that it's sort of generating the answer, I think, in a noised fashion. I'm going to have to like take this video and slow it down so I can actually see what's going on here. So if you see it kind of like a little repeat right here where it actually shows it slowed down, the video slowed down, because I'm super curious what it's doing. I think it's actually denoising. So it's starting off with random letters and stuff, and it's denoising it into the answer. That would be my guess, but it's so fast that it's really, really hard to see. All right, so clearly we're able to do things outside of coding. So I'm going to go ahead and ask it. This is a Beaufort cipher, which every other system has had significant problems trying to figure out. So I'm curious if the Mercury coder is going to be able to get this on its own. Unfortunately, it looks like we're a little bit stuck here. It's into that thing, so I may have to like reload the page and start over again. I've had to do that a couple of times to get it to work again, but maybe it will go ahead and start. Not exactly sure. Oh yeah, that was interesting. The quick brown fox jumps over the lazy dog. Okay, so it got absolutely wrong, but I could see it. It was a little bit slower this time, and I could see that it was basically denoising the answer. So, you know, this was a very challenging question, and it's a coding thing, not it's not designed to do ciphertext. But I just thought it would be interesting to throw that at it. So it's a definite fail, but it did make an attempt at it. All right, and just for the heck of it, let's see how it does on creativity. I said, write me a bedtime story about cipher codes for my 2-year-old grandniece. Once upon a time in a magical land called Codeville, there lived a little girl named Lily. Lily loved to explore the world around her. One sunny afternoon, looked like this. Oh, cool. So it actually did a cipher. She knew this was a cipher code. Okay. I mean, it's probably not the greatest story in the world, but looks like it has the correct format and everything. So even though this says it's a coding only, you know, thing, you can see that it was cross-trained and it's able to work on multiple different types of environments. So I think that's really, really cool. And I really love the way it sort of undiffuses the text as it goes. That's a really, really cool effect. And again, that's enabled by clicking this little button up here. And just for one more interesting thing, they have a suggestion here, make a particle system where particles follow the mouse cursor. So that sounds pretty cool. So let's go ahead and ask it to do that for us here. And there we go. So it goes into this sort of pre-phase. Wow, it's just so cool watching it. Yeah. You could see it's actually sort of like it's diffusing it down. You can see it becoming more and more like the ultimate answer. So that's really cool. So, JavaScript, HTML. So we've got this, unfortunately, let's say, can we do this in Python? You do this in Python instead. I just don't want to have to deal with web browsers and crap like that. So let's see how it does it. Oh, so there's actually this little effect over here too. That's interesting. That's the first time I've seen that. So it's still going to ask me to do it in, okay, Python, create a Python script, import Pygame. Okay, so hopefully this will work. Let's go ahead and give it a shot. We're going to go ahead and copy it over the Space Invaders code, and it's significantly shorter. It's only 82 lines long. So let's see, and fingers crossed, we'll actually get something that will work. So I realized it's asking for a WebSocket server, and again, I just don't want to deal with that crap right now. So I've asked it to just do it in a Python window instead, which I'm a little bit confused why it didn't do that in the first place, but hopefully that will work now. So it's got up arrow, down arrow, left arrow, handles key presses. Oh, maybe it just can't deal with the mouse in that. So yeah, okay, so we'll just do key presses instead. So randomized color. All right, so let's go ahead and give it a shot. I will copy this over and we will run it, and hopefully Pygame will start. There we go. Okay, whoa. Oh, it does have mices. So yeah, it's still using the mouse, so I don't know why it was saying so. Let's see, randomized color. Oh, cool. Oh, wow, that's fun. So I can press, wow. Okay, so that's a pretty darn cool effect, right? I think that's pretty neat. Moving across, it's randomizing the colors as we go. Wow, so that, all right, I don't know, maybe I'm easily entertained, but I think that's pretty cool. Alrighty, and if it goes off the screen, I guess it just goes ahead and generates it. Yeah, so you could think about iterating this, but that's pretty cool. I like that. Let's see if it'll do a tesseract. While we're on this subject, one more thing to test out. Let's see if it'll do a tesseract. All right, so I said, can you create an animated tesseract? Certainly an animated tesseract, step 1, install libraries. Okay, with the red ball bouncing around inside it, pip install Pygame and NumPy, I've already got that, so no big deal. Tesseract size, okay. So it's got, oh, this is cool. It actually has explanations and stuff. Let's go ahead and fire this up in VS Code again. All right, weirdly enough, in my base environment, I did not have SciPy installed, so that was rather odd, but hopefully it will operate now. And so it threw an error, and now I've hit my rate limit. So, oh, bummer. Okay. So anyway, that's as much testing. I really was hoping to see the tesseract. I will include a quick video of it if I get, while I'm editing this, I get back in, I'm allowed to re-ask the question. All right, and back to the paper. Welcome to my ADD brain. I love to go back and forth between things. I'm not going to read all of it. Of course, I will leave a link to this in the description, but again, it's just inceptionlabs.ai. So super easy to go to. You don't even need the link. Anyway, our vision next generation LLMs powered by Diffusion. Current large language models are autoregressive, meaning that they generate text left to right, one token at a time. Generation is inherently sequential. The token cannot be generated until all the text that comes before it has been generated, like I was talking about earlier, and generating each token requires evaluating a neural network with billions of parameters. Frontier LLM companies are betting on test time computation to increase reasoning and error correction capabilities, but generating long reasoning traces comes at the price of ballooning inference costs and unusable latency. Yes, to both of those, I have experienced those both in a professional sense. They kind of suck. A paradigm shift is needed to make high-quality AI solutions truly accessible. Diffusion models provide such a paradigm shift. These models operate with a coarse-to-fine generation process. In other words, they think kind of big and coarsely and then narrow down what they want to do, which, like I said, gives them access to a whole picture rather than one token at a time. So very different way of thinking, much more holistic, a lot of the way that humans kind of think about problems when we're not thinking specifically linguistically. So really, really cool. Anyway, a coarse-to-fine generation process where the output is refined from pure noise over a few denoising steps as illustrated in the video above. Because diffusion models are not restricted to only considering previous output and at structuring their responses, and because diffusion models can continuously refine their outputs, they can correct mistakes and hallucinations. In other words, during the denoising process, they can go like, oh man, I was hallucinating during this. So for these reasons, diffusion powers all of the most prominent AI solutions for video, image, and audio generation, including Sora, Midjourney, and Refusion. However, applications of diffusion to discrete data such as text and code have never been successful until now. Dun, dun, dun. And then they talk about how much faster they are, how they're going to have APIs, how they win all of these tests and all that kind of stuff, right? Standard stuff. And then we can see Claude, ChatGPT, and Mercury, crushing it. Mercury, again, great name, much better than ChatGPT. Claude is a great name. Mercury is a great name. ChatGPT. OpenAI just sucks with their naming conventions. Anyway, so then you've got what this means for AI applications. You can sign up for API access, and I already did that. And what's next? Let's take a look at this. Mercury Coder is the first in a series of upcoming DLLMs, so that's cool. A model designed for chat application is in closed beta, so that will be more general than this coder. Diffusion language models will unlock new sets of capabilities for LLMs, including improved agents. DLLM speed and efficiency make them ideal for agentic applications that require extensive planning and lengthy generation. 2, advanced reasoning. DLLMs can leverage error correction to fix hallucinations and improve answers while still thinking in seconds, unlike current autoregressive reasoning models that take minutes. minutes. So that's really, really cool. It'll be able to reason much, much more quickly. 3, controllable generation. DLLMs can edit their output and generate tokens in any order, allowing users to infill text, align outputs with objectives like safety, or produce outputs that reliably conform to user-specified formats. That could be a huge unlock. It could be a thing where it's able to basically safety check itself as it's denoising this thing and going like, wait, am I being jailbroken? Am I generating tokens that could be considered dangerous or harmful or something? And it could fix that problem as it's denoising the answer. Super, super cool. And then for edge applications, this is interesting too. So this means edge compute. So, like, like this guy on my phone or something like that, rather than having to have these gigantic models, we might be able to do this on the edge. Given their efficiency, DLLMs excel in resource-constrained environments, such as edge deployments on phones and laptops. So another huge potential unlock. So again, while this is clearly generation 1 of these diffusion large language models, you can see the possibilities in the future and how much more effective this could be in certain domains than these transformer-based models. And I have been saying for a long time that we need another revolution past transformers to get to artificial general intelligence, or something that even approaches consciousness, the ability to kind of think in a more holistic manner. And while large language models with chains of thought have approached this, they've gotten a lot further than I thought they would. I still think they're very, very limited by their linear only thinking. They're having to generate one token at a time. This is very, very different. Again, if you've ever watched a diffusion model work for an image, it starts off with noise and then you start to see the image come out of it. And over time, after 20 steps or 50 steps or however many diffusion steps you do, you can see the actual image, be generated. And then you're like, holy mackerel. And now, I mean, we generate images that are so good, they're almost indistinguishable from real images. And we're getting there for audio and for video and things like that. We're not there yet, but we're getting there. And while generating tokens you might think of as discrete and very different, when you're doing an image or something, it's pixels, and pixels are discrete. You have 640 by 480 pixels. That's how many pixels you have. Each one of those is a discrete value. So ultimately that's a number, and what you're doing is replacing that number by a token. I mean, ultimately, even words are numbers to computers. They're in a vector embedded space. They're just some sort of vector that sits in a high dimensional space. And so each one of those tokens is ultimately a number, which is just a value that sits in a high dimensional space, just like the pixel in an image is. And so ultimately denoising words as opposed to denoising pixels is not that weird and not that big of a stretch. And you can see that it works, and it works really, really fast. And while this is certainly not up to the capabilities of something like ChatGPT o3 Mini or Mini High right now, it can't reason to that extent. It's not that generally useful. You can already see that it's way faster, and you can see that it thinks in a very different way. And you can imagine with these, 4 things that they have here, and potentially many, many more, that the headroom, the growth potential for diffusion large language models could be really, really big. And we could, over the next, 12 to 18 months, see a massive improvement in the capability of large language models based on this new paradigm. And potentially, like I said earlier, with a hybridized sort of system where you could use transformer-based architecture to sort of input things into a liminal space, this could be used to play around with it in that liminal space in a very, very holistic sort of manner. And then potentially you could use a large language model that's based on transformers on the output side, although this seems to do very, very well about outputting on its own. So anyway, some sort of hybridized system certainly is not beyond the bounds of possibility, but this by itself already works pretty amazingly. And I think it's just amazing that Inception Labs has gotten this working and working as effectively as it does. So a big congratulations to the team. And again, if any of you guys want to come on my channel and talk about this stuff, I would love to. That would be super, super cool. I'm a big fan of diffusion models. Alrighty, folks, if you can't already tell, I'm super excited about this new paradigm. I think it's amazing. Super, super cool. If you enjoyed the video, please do like it so other people can find it. And if you enjoyed this kind of content, please consider subscribing. Most of you are not subscribed, and I would appreciate it so much if you would take a second to click the little subscribe icon. That would be amazing. And in the meantime, I will see you in the next video. Bye-bye.